Okay, so today I'm going to look at balancing of chemical equations, and it's a topic that I've had a lot of students, comment in the comment section and message me privately while not understanding. This is a topic that is going to help you to understand other topics in chemistry, whether you're doing integrated chemistry or the elective chemistry. If you are studying something like more concepts and if you are really doing science into details, this topic is very important. You should know it. So I would advise that watch the full video because at the end, I have something for you. Now, before you will be able to balance chemical equations, you should have foundational um, knowledge in certain areas. Now, this includes your knowledge on valency should be very strong, writing of chemical formulas of certain classes of compounds. They include binary compounds, oxo anions, and then diatomic molecules. Why? Because these um, elements exist naturally as molecules. We have hydrogen, chlorine, bromine. Now take note, these are halogens. Nitrogen, oxygen, and so on. So even though I've already taught valency in one of my playlists, I would want to go over it because of how important it is in balancing of chemical equations. Not just that, but also the formation of ions. Now, when an element has one, two, or three valence electrons, it ends up losing. So in mathematics, when anything is lost, it's minus. But in chemistry, when anything is lost, it's actually plus. So when there are five, six, or seven valence electrons, what happens is the element would have a negative charge. So why will it have a negative charge? It is gaining. How many is it gaining? When there are five, it's actually gaining three to be eight. When there are six, it's gaining two to be eight. And when there are seven, it's gaining one also to add up to eight. So take note of that. So back to valency. So let's pick an element like lithium. Lithium has an electron configuration of 2, 1 because the atomic number is 3. Now, since it has one electron on the last shell, it is going to have a charge of plus. This is lithium ion. So there's no way in chemistry you see lithium ion to be Li2 plus. No, there's nothing like that. If you know your first 20 elements, you can write your electron configuration. You should be able to figure out the valency for mostly you have elements in group 1, group 2, and then group 3. So elements in group 1 have a charge of plus 1, elements in group 2 have a charge of plus 2, elements in group 3 have a charge of plus 3, and that makes it very simple. Now, when it comes to 5, 6, 7, elements in group 5 have 5 electrons on the last shell, 6 electrons, and it goes on like that. So now take note, when we pick an element like phosphorus, phosphorus is the 15th element. So 2, 8, then 5. How many do you add to 5 to get 8? It's 3. So the valence for phosphorus will be 3, but the charge will be 3 minus. So that's how you write phosphorus ion, P3 minus. So it runs through for all the other elements that are in group 5, group 6, group 7. So try this out yourself. What do you think the valency for chlorine will be? Chlorine has 7 valence electrons. So since it has 7 valence electrons, you just need 1. If you need 1, just put negative there. Now take note. When you are writing, it's supposed to be negative 3. But because it's chemistry, you don't write negative 3, write 3 minus. And when it's 1, that's for the chlorine, just put minus. So we begin with our first example. Write a balance equation for the following. So sodium and then chlorine. So the chemical symbol for sodium is capital N A plus chlorine Cl2. Now, why did I put 2 here? Because chlorine is a diatomic molecule. Now take note, with metals, you don't put any number by them, meaning it's just one that is there. In chemistry, when it is 1, you don't write it. Then you bring your arrow, then your product. Now take note, whatever you have on the left side, they are called reactants. And what you have on the right side is called the product. Now you don't just write your whatever you are seeing on the left, you are not just writing the same thing. What you are going to do is you are going to write the chemical formula. Now, your knowledge in valency will help you with writing the chemical formula. So you don't just see, okay, I have Na and I have plus Cl2, so I just write the same thing there. No, you follow a certain procedure. So follow me. So sodium, capital N, A, then chlorine. What am I doing? I want to write the chemical formula. That is the product. What's the valency for sodium? Sodium has an atomic number of 11 and it has one electron on the last shell. So the valency is 1. Chlorine, 7 on the last shell. Valency is also 1. So you exchange. So you are going to have NaCl. Now, this is not balanced. You have sodium here with 1 atom, 2 chlorine atoms. But writing the product, following the principles behind writing of chemical equation, we ended up with sodium having 1 atom and then chlorine also having 1 atom. Now, just follow me and pay attention. I'm going to write my sodium here, Na and then Cl. Now, whatever I have on my left, I write the same thing on my right, Na and then Cl. Now, when you are balancing chemical equations, for the sake of what we are doing, always leave a space. There should always be a space in front of the chemical symbol because you always use whole numbers to balance chemical equations. Even with the product here, you can see that I left space here, there's space here, there's space here as well. The next thing to do is to write the number of atoms. So you have sodium here. How many atoms of sodium do you have? You just have 1. How many atoms of chlorine do you have here? You just have 2. How many atoms of sodium do you have here? 1. How many atoms of chlorine do you have here? It's also 1. As I said, you balance with whole numbers. Now, sodium, you have 1 atom of sodium, 1 atom of sodium. Chlorine, you have 2 atoms. Chlorine, you have just 1 atom. You balance with a whole number by multiplying the whole number. In this case, so this 2, this 1. What number do I multiply by this to get 2? It's 2 times 2. Now, if I've multiplied this by 2, you expect that the 2 should affect just the chlorine. But in chemistry, whenever two substances react, the product you have is also a different substance. For example, this is what we use to give food its taste. That's sodium chloride. But sodium is very reactive. Chlorine is poisonous to the body. But when sodium and chlorine react, we have something that helps us to season our food. So this is a new substance that is formed. So this 2 here is supposed to affect everything. So the 2 comes in front. Now, because I've written the 2 here, the 2 is now going to affect the sodium as well. So now we have 2 here. Now, anytime you write a number in front of a chemical formula, the number that is in front multiplies the subscripts that you have. So right now, sodium has 2 atoms. So what do I do? I just have to multiply. So since I have 2 atoms of sodium here, in a course of balancing the chlorine, it now affected the sodium. So what do? You realize that on the left side as well, it's also not balanced. So I also multiply by 2. Why do I multiply by 2? I want them to be balanced. So take note, you always use whole numbers in this case to balance the equation. So because I multiplied by 2, I now have to also put 2 in front here. Now let's check. Whatever you have on the right side should be equal to what you have on the left side. So it's balanced. I have 2 on the 2 atoms of sodium on the left, 2 atoms of sodium on the right, 2 atoms of chlorine on the left, 2 atoms of chlorine on the right. So it's just looking at it, understanding what you are doing, knowing all the principles, and then following them. So I'd like us to look at a second example so that we can understand it better. But if you think you got what we did in the previous question, kindly pause, then try it yourself. Otherwise, follow me. Let's go. So we have hydrogen and then chlorine. If you recall, hydrogen is a diatomic molecule. Chlorine is also a diatomic molecule. So you are going to have H with your 2 plus Cl also with your 2. Now you can see that I leave space here as well. My arrow comes. Remember, you use the principle of writing chemical formulas with your knowledge in valency. So you have H and you have Cl. So hydrogen atomic number is just 1. So if it has 1, now take note, the first shell just needs 2 electrons. So it's going to be lost. So you're going to have valency of 1 for hydrogen. Chlorine also has 7 electrons on the last shell. Means you need 1 to add up to it. So chlorine also has 1. So you exchange the valencies, you are going to have HCl. So we are going to we are going to compare the number of atoms and then use whole numbers to balance them. So H here, Cl here, H here, and Cl here as well. How many atoms of hydrogen do we have here? We have 2. How many atoms of hydrogen do we have here? We have 1. Chlorine here, we have 2. And chlorine here, we have 1. Now, there's something interesting happening here. You can see there is 2 here and there's 2 here. There's 1 here and there's 1 here. Now, anytime you are balancing, balance one after the other. Because if you remember in the previous question, when we balanced chlorine, it ended up affecting sodium. So just pick any one, just one, and balance that one first. Because when you balance, it ends up affecting others. So if you are going to multiply 2 by this and 2 by that, you're going to make the work more complicated. So I'll go for the hydrogen. Just multiply by 2. And as I said, this is a new substance. So since this is a new substance, I'm going to put the 2 in front of the hydrogen chloride, and it's going to affect the chlorine as well. So I put my 2 in front. So the 2 is affecting the hydrogen. It's also affecting the chlorine. So you see that with just one move, everything is balanced. Now, balancing of chemical equations is very dynamic. So you don't just stick to one method and say, this is how I go about it. No. Always remember your diatomic molecules. Write your chemical formulas rightly with your knowledge in valencies, and you are good to go. So we move to the next question. So this is the third question, and we have hydrogen and then oxygen. So you write the chemical symbols. So hydrogen plus oxygen. Now remember, hydrogen is diatomic. So you put your 2 here. Oxygen is also diatomic. Put your 2 here. Now, the chemical formula. Hydrogen, oxygen. The valency for hydrogen is what? Can you help me? Okay, the valency is 1. If you remember from our previous question. Now, oxygen. It has 6 valence electrons. How many more does it need to add up to it? 2. So the valency for oxygen is 2. Good. Is it ringing anything? So now you know why the chemical formula for water is coming from. H2O. H2O. Now we are going to compare the number of atoms on the right and on the left. Now, if you look at it critically, you realize that it's actually not balanced. So H and then O. H and then O. So you have 2 atoms of hydrogen. 2 atoms of hydrogen. Then the oxygen. 2 atoms of oxygen. Oxygen as well. Over here is just 1. Hydrogen and hydrogen is, they have the same numbers. The one on the left and the one on the right. On the left, we have oxygen to have 2 atoms. But on the right, we have oxygen with just 1 atom. You balance with the whole number. So you multiply by what? 2. Now, if you multiply by 2, the 2 is supposed to affect only the oxygen. But because there's a new substance formed, the 2 affects the whole thing. Now we check again. Now this 2 is going to multiply this 2 down here. So you're going to end up having 4 atoms of hydrogen. Sorry. So I multiply by 2 first before I write the 4. Oxygen is balanced because the number of atoms you have on the right is the same as the one you have on the left. Now, since this is 4, this 4, we have 2 atoms of hydrogen on the left. What number do you multiply by 2 to get 4? You multiply by what? It's 2. If I've multiplied by 2, I have to write this 2 in front of the hydrogen molecule. So I put a 2 here. So 2 times 2 is 4. 2 times 2 is 4. I have 2 atoms of oxygen on the left, 2 atoms of oxygen on the right. And it's balanced. So this is number 4 and I've increased the difficulty level a little, but I always say that the higher you go, the more easier it becomes. So let's roll. So we have magnesium plus hydrogen chloride. Hydrogen chloride is a binary compound. And since it's a binary compound, you have to apply your knowledge in writing of chemical formulas. So hydrogen chloride, H and then Cl. Hydrogen has a valency of 1. Chlorine also has a valency of 1. So HCl. Now take note, you don't write 2 by the hydrogen or the chlorine. Why? Because you are dealing with something that is different. Even though individually they are diatoms. They are diatomic molecules. Yes. Now stick with me here. Stick with me here. Stick with me here. In order to be able to write the product, stick with me. Magnesium is a metal. Hydrogen chloride, binary compound. Now, in writing the product, you want to mix something up. It's like, you're trying to mix something up. Magnesium here, and then hydrogen chloride. What you're going to pick the individual elements and then state if they are cations or anions. Now, remember what I explained about how to determine the valency. And I mentioned something about when an element has 1, 2, or 3 electrons on a large shell, it loses, so it has a positive charge. And when an element has 5, 6, or 7 electrons, it gains to add up to 8. So it has a negative charge. So you are going to establish that anytime you have an atom and then a compound reacting, or a compound and a compound reacting, so that you can know which atom is going to bond to which atom. So you have magnesium here. Magnesium has 2 electrons on a large shell. It has an atomic number of 12. So if it's 2, it's going to have a positive charge. All you need is just the plus or the minus. That's all you need. Take note. So magnesium is positively charged. Hydrogen just has 1 electron on a large shell. It's going to lose. So it also have a positive charge. Chlorine has 7. So it's also going to have a negative charge. So positively charged atoms are going to bond to negatively charged atoms. That's what's going to happen. So magnesium will go for chlorine. Magnesium will go for chlorine, and the hydrogen will stand alone. Now, for me to be able to get the whatever I'm going to get when I react magnesium with chlorine, I have to use the chemical formula principles. So I have Mg and then Cl. How do I know that Mg is supposed to react with Cl? I know because magnesium is positively charged, chlorine is negatively charged. A positively charged ion will not react in this case with a positively charged ion again. So it's positive going for negative. In subsequent questions, you understand it better. So magnesium has 2 electrons on a large shell. So it's going to lose the 2. Chlorine has 7, it's going to have 1. You're going to have 1 here. So when you exchange the valencies, you are going to have Mg. Now 2 is going for the chlorine. MgCl2 plus, you just have hydrogen here. Don't forget, hydrogen is a diatomic molecule. So instead of just writing the H and then leaving it, you have 2 by it. So take note, you don't write a 2 in front because you're not trying to balance. So with the diatomic molecules, anytime you are writing your first equation, once they are standing alone, they should have 2 by them. Now you are going to balance. Follow me, very, very simple. So you have your Mg, H, and then Cl. Now the same order you wrote on the left, make sure you write the same order on the right. So how many atoms of magnesium do you have? It's 1. Hydrogen is 1. Chlorine is also 1. On the right, magnesium is 1. Hydrogen, you can see it's 2. Chlorine is also 2. So you realize that hydrogen and chlorine, they are not balanced. And don't forget what I said. I said, when you realize that you can balance 2 elements or 2 atoms at a go, just balance 1 because it might affect the other. So what you need to balance is on the left, either hydrogen or chlorine. So I pick hydrogen, multiply by 2. If I multiply by 2, you realize that the 2 is actually supposed to affect the hydrogen and then the chlorine. So you realize that the chlorine will end up being balanced, even though he didn't focus on it. So I put my 2 here to realize that the chlorine also be affected. Times 2. So this is balanced. So this is the 5th question. And as I previously said, the higher you go, the more easier it becomes. So just follow me. You are seeing some unusual atoms here. You have zinc and you have copper here. Now, this is called copper 2 tetraoxosulfate 6. Yes, don't worry about the name. You can check my playlist to see how these salts are named. Now, zinc has a valency of 2. It has a charge of plus 2. Now, it's not part of the first 20, so you might not be able to determine it. Now, I'll use this opportunity to also give you other elements or other atoms that have valencies that you are supposed to know. So we can have copper here. So copper has a charge of plus 1 or plus 2. So it means that copper can have a valency of 1 or 2. We can also have lead plus 2 or plus 4. So it means that lead has a valency of 2 or 4. Then we can also have iron plus 2 or plus 3. Now you are supposed to memorize these, and you see why in a second. Now for the zinc, we know it's a metal. Metals are positively charged. So we have plus for the zinc. Copper is also a metal. So plus. Now you can see SO4 here. Now remember, in the first part of the lesson, I mentioned that you are supposed to know how to name oxoanions. Now, SO4. SO4. You should know your oxoanions very well, to the point where you even know the charges, the overall charge of the oxoanion. So for example, SO4, the charge is 2 minus. If you have CO3, 2 minus. Let's check the playlist. You find videos on this and you'll be able to commit them into memory. Why should you know the charge for SO4? It will help you to know how this salt was formed. Let me go a little bit into the salt. So you have Cu and then SO4. Now have in mind that since SO4, which is an oxoanion, has a charge of an overall charge of 2 minus, the valence is actually 2. Copper has a charge of or a valency of 1 or 2. Now let's just assume that it was 1 that was used. If it was 1 that was used and you do your crossing, you are going to have Cu2SO4. This is not the question. Why am I trying to know the valency? So that I will know what to write at the product side. Because if I don't know the valency that was used here, I will not know what to write. So knowing the valency that was used over here would give me an idea that, okay, it was 1 that was used or 2 that was used. Oh, it's very simple. Just follow. Just follow. So it wasn't 1. So it's either 1 or 2. So I put 2 here. Now when you're writing chemical formulas and then the numbers are the same, they cancel out. So 2 here, 1, 2 here, 1. They cancel out in terms of like multiplication. So for example, if you have, let's say, 4 and 2, 2 cancel 2, 1, 2 cancel 4. So you have 2 then do the exchange. All right. So SO4 has a charge of minus. Great. So you have zinc being positively charged, zinc ion being positively charged, copper ion being positively charged, and SO4 having a negative charge. And remember, zinc is going to bond to whatever is negatively charged. So zinc is not just going to bond to the sulfur here, it's the SO4 we are dealing with. So we have zinc and then SO4. Principles for writing your salts or whatever chemical equation you would have. Zinc has a valency of 2. SO4, sulfate 6 ion, also has a valency of 2 because it has a negative 2. So you exchange, you are going to have Zn. Okay, before I write it, 2 here, 1, 2 here 1. So ZnSO4 plus. Now, what we have here is just copper. Copper is not diatomic, so we can just write copper, Cu. All right. Is it balanced? Is it balanced? Is it balanced? It looks like it's balanced. Okay, so let's check if it's balanced. So you have zinc here, copper there, sulfur, and then oxygen. So the same order: zinc first, copper, sulfur, and then oxygen. So let's check number of atoms for zinc is 1. Right. Copper is also 1. Sulfur is 1. Oxygen is how many? 4. So for the right side as well, the product, zinc is 1. Copper is 1. Sulfur is 1. Oxygen is 4. So this is truly balanced. So this is the end of the lesson on balancing of chemical equations. But with balancing of chemical equations, one of the best things you can do for yourself is to solve questions. So these are just a few examples you can try your hands on and then post your answers in the comment section. Try it yourself. And you would have myself and other, learners like you commenting and, bringing minds together to see how you can perfect your skill in this lesson. Thank you. Subscribe, like, and then share with your friends.